for challenge problem 4, we have this fluid moving down this stationary wedge with this belt moving backwards. We're going to assume it's steady state, fully developed, uniform pressure, and that has no edge effects. Because it's steady state, pressure does not change with time, so this is 0. Because it's fully developed, that means the velocity does not change with respect to the direction it's flown, which means this is 0, and because no edge means this is 0. So then we get dvy over dy is equal to 0. Moving on to the x momentum equation, we know steady state, so this is 0, and from the previous equation, we know this, and this is 0. Constant pressure means this is 0, and again, for the previous equation, we know this and this is 0. So then we're just left with the shear force, and then the force from gravity per unit volume. And then once we integrate twice, we get these equations. To solve for C1 and C2, we use our boundary conditions, which is also we are going to assume no slip. So our boundary conditions are at y equals h, the velocity has to equal negative vb because it's moving backwards, and then at y equals 0, because it's stationary, the velocity is 0. So once we know that, we can solve for C1 and C2, and then we can get this equation for velocity in the x. And then to find when the velocity vb, so that the net velocity is equal to 0, we have to integrate from 0 to h. So like imagine you find the area under a curve, and you want to find when the net area is 0, you have to integrate from 0 to h and then set equal to 0. And then that's how you get this expression, VB. And then, like I said earlier, so like this is the velocity profile, so it's not to scale, but this and this are like same in area. So that's basically what we did and why we integrated from 0 to h and then set equal to 0. But to draw the velocity profile, we know that at y equals 0, the velocity is 0, and then at y equals h, that it's negative vb. So then we just have to find the maximum velocity and when it crosses over. To find the maximum velocity, we just take the derivative, set equal to 0, and then you know at what point at h it is, and then you can plug it back in and then find the maximum velocity. And then to find when it crosses over, you can just set the velocity equation equal to 0, and then solve for h that way. So then you get it happens at 2/3 h is when it crosses over, and at 1/3 h is when it has the maximum velocity.